All right, so this is a continuation of our Lab 7 carbohydrate catabolism presentation. So, all right, fermentation. Fermentation is the breakdown of organic molecules to harness energy without undergoing oxidation. So there's no removal of electrons. Usually happens after glycolysis. So instead of going to the mitochondrial matrix, fermentation stays in the cytosol. There's lactic acid fermentation, which refers to the breakdown of glucose to form lactate. And compared to oxidative phosphorylation, fermentation produces a lot less ATP. So the complete breakdown of glucose in the presence of oxygen yields around 34 to 38 ATP molecules, whereas anaerobic conditions yield only about 2 ATP molecules. For the experiment, we had 3 beakers. The first had glucose, the second had starch, and the third had starch with, the third had starch with 15 milliliters of amylase, which we measured out using a graduated cylinder. We incubated this beaker for about 15 minutes at 37 degrees Celsius to put the enzyme in its active form. Afterwards, we used our fingers to crumble 3 pieces of 1.5 grams of yeast into each individual beaker to ferment. We then stirred each substance with a glass rod until it dissolved, as you can see in the pictures. Okay, so let's see. The contents of each beaker were then poured into their corresponding labeled fermentation tubes, which we have a convenient video of right here. The tubes were then placed in water baths at 37 degrees Celsius for an hour to see the gas accumulating in the tails of the fermentation tubes. We measured gas production at 20-minute intervals from the tip of the tail to the solution level. This data was then used to calculate the volume of the gas involved. So here we have a video of us actually preparing the fermentation tube for starch, I think. All right, let's see.
Looks like 3/4 full. Do you think that's good? Yeah. Okay. So now we're going to cover it and go like this. Stop the video? Turn it back. Oh, you can't see it? No, put it back. Yeah, you're done.
And these are our 3 fermentation tubes after an hour of incubation. You can really see how much has fermented and how much gas was produced from, like I said before, the tip of the tail to the beginning of the solution level.
Our results. We have them conveniently put into a table, and we show you the times that we stopped it out of the area where we were incubating it so that we could measure it in centimeters how much gas was produced. So at 1042, the starch and amylase was at 0 centimeters, the starch was at 0 centimeters, and the glucose was also at 0 centimeters, which is kind of to be expected because the fermenting couldn't happen so quickly. 1101, we saw slightly better results for glucose at 3.8 centimeters, but starch with amylase and irregular starch were still at 0 centimeters. At 1122, starch with amylase still was at 0 centimeters, and the starch by itself was only at about 0.9 centimeters, while glucose had already 11.4 centimeters. At 1144, it increased a little bit at 1.2 centimeters. starch at 2.4 centimeters, and glucose at 11.6 centimeters. So this can really give us our conclusion that glucose produced the most gas and starch the next amount, but starch and amylase produced the least.